Hello, I'm Fred Cummins. I'm the module coordinator for Connectionism and Dynamical Systems, which is Comp 40260. In the School of Computer Science, we have 3 modules devoted to connectionist computing, or the field of artificial neural networks, as it's sometimes known. Alongside this module, we have Comp 41390, Connectionist Computing, and Comp 47650, Deep Learning. And I want in this video just to provide some guidance as to what distinguishes the present module from those other 2. Connectionism, or artificial neural networks, have a history that goes back 70 years now, 60, 70 years. In that time, there's been waves of activity from early models that were inspired by considerations of the brain, to a second wave in which a newly resurgent bunch of models that could learn from data were applied to theorizing about human cognition and development. And since the onset of this millennium, a third wave has appeared in the field of deep learning, which finds great application in data science. Now, in the deep learning module, you'll be taught state-of-the-art techniques for dealing with very large data sets in a machine learning context, where the examples discussed will be things like the image understanding and language modeling by machines. In the connectionist computing, you will get some information about the early stages of connectionism and their relation to cognitive science. But the focus again will be on the last 10 to 15 years of developments in the field, and the area of application will by and large be biological modeling. This module is different. Here we will focus primarily on the second wave, that is work done in the 1980s, 1990s, because our concern is to understand how scientific modeling works in the context of the broader aim of understanding human cognition and learning. Here, there's a lot to be learned from connectionist models, and they were very important in those decades for informing theories in cognitive science. I would argue that they are no longer of that kind of importance. Their exploitation in the field of machine learning and data science has nothing to do with the original concerns of brain science and cognitive science. And so our stance here will be to understand what scientific modeling is and how one can approach very difficult topics using specific kinds of formal tools. We will not be paying attention to the last 10, 15 years, except from a critical stance, that is, in order to understand how the development of such techniques feeds back into popular notions of the person and into the political situation. The second half of the course will lead then into a different formal vocabulary that finds increasing application in studying human cognition. And this is the world of differential equations, of dynamical systems. It's the natural language of the sciences, commonplace in physics and chemistry and biology and ecology and economics, and now increasingly turned to characterize human behavior and human experience. So if you're interested in scientific modeling of the human, and you are willing to consider various critical and historical perspectives, this module is entirely for you, and it does not require any prior competence in computer science. If you are interested in getting up to speed on machine learning and the application of neural networks in contemporary data science, then either deep learning or connectionist computing is for you. I hope that's clear.